Hello everyone, and welcome to NSTA Web Seminars, where you can find live interactive learning at your desktop. My name is Bryn Slate. I'm the coordinator of web seminars here at NSTA, and I am moderating tonight's program. Joining me from NSTA headquarters is Paul Tingler, and he is available to answer your technical questions during tonight's live program. Tonight's presentation is sponsored by NOAA, USFS, and NIEHS, and it is titled New Climate Tools for Educators. And our presenters are Amy Work, Mark Becker, and Peg Steffen. And now I'll pass it over to Amy.
Thank you, and good evening, everyone. So I am going to talk a little bit tonight about a tool that we're developing for looking at the impacts of climate change on human health. And as we go through this, if you have any questions, you can type them in the chat dialog box, and we'll also take some time for questions throughout, as well as at the end of this demonstration. So where am I actually talking to you from tonight? I am based at the Institute for the Application of Geospatial Technology, which is in the Finger Lakes region of New York State, and our project partner is based at the Center for International Earth Science Information Network, or CSIN, which is located on the Lamont Doherty campus of Columbia. So calling you from New York tonight. And what our project is actually looking at is the impacts of looking at climate change impacts on human health. And so we want to be able to provide educators the tools and the resources necessary to look at these two issues together in a tool to be able to look at these relationships in these complex situations. And so ultimately, by being able to provide the resources and the tool, hopefully we can get students to start to explore these dynamics between a change in climate and what that means in terms of humans across the globe. So when we take a look at climate and health, we're talking about a variety of different things, but climate governs a lot of the human variables that we deal with and that govern our lives. So looking at the availability of water, agricultural productivity, looking at heat and humidity and what that means in terms of respiratory problems, as well as air pollutants. Vector-borne diseases such as malaria or dengue, and then also looking at severe disasters such as storms, hurricanes, and what that means in terms of a shifting landscape that we might see, as well as rising sea levels. So all of these factors are coming together. What does that mean to humans across the earth? And so when we take a look at some of the impacts of climate change on human health, we're seeing that climate change varies by region as well as over time. And so it's not going to hit every area the same, and it's not going to hit every region in the same manner either. So understanding these differences that take place, as well as where they take place. And so there are some localized benefits that we'll see in terms of climate change, such as fewer deaths within the wintertime, and also an increase in food production within certain areas, such as bananas. So there will be positive effects, but there will be a lot of negative effects, and most of the impacts from climate change are likely to have a negative impact on the human health. And so looking at people and what do they have to do to adapt to some of these changes that we'll see. So now we're going to take a little bit of interactivity here and understanding the climate responses that people are taking from the local grassroots level to government level to international levels. And looking at water quality and quantity, one of the things that is known is that the number of people are already living in water-stressed areas. But what will a change in climate mean to people living in water-stressed basins by 2050? And so on your screen there, you have the letter A. So go ahead and take a vote, and we'll just take a few seconds here. So what do you think the number of people will be living in water-stressed basins will be by 2050?
Okay, everyone, your poll buttons are now active, so you can use your that button to select A through E to submit your answer, and we'd appreciate having everybody give us their input because it continues to make the program interactive and interesting for us. So everyone take just one moment to submit your vote. Okay, and after just one moment here, I will lock the responses so we can publish our response answers to the whiteboard. And there they are, Amy.
And so we see that most people, it's not going to be cut in half, so we had no responses there, but most people thought that it would actually triple by 2050. Well, it will actually double by 2050. So that's just one thing, but based on population changes as well as the change and the dynamic of the precipitation patterns, this could also change. And so it's one of these, it's a dynamic and it's an evolving situation that's going on, but it's expected to double by 2050. So let's take it another situation and looking at food security. And so climate is likely, the change in climate is likely to have an impact on food security, going all the way from the agricultural yields all the way up the food supply, and even affecting the livelihoods of those individuals who rely on agriculture as a source of income. And so here's another question to pose to all of you. And looking in some African countries, yields from rain-fed agriculture by 2020 may A, B, or C. I think your controls are still active to go ahead and select A, B, or C. And it would be great to have everyone participate. And we'll take a few minutes, and then Bryn will go ahead and display the results.
Okay, and we'll give just one more moment for those who are still trying to locate the poll button to find that and submit their answer. It looks like we've got about half of the participants who've submitted a response to this poll, so it would be great to have a few more. And just one more moment, and I will lock the responses and publish them to the whiteboard.
So besides those that didn't answer, the percentage of you actually selected that yields will actually be cut in half, and that's true. And so understanding how that will impact not only the quantity of food, but also the livelihoods of the people that are relying upon agriculture as a source of income. And so this will also have other effects, not just based on food production as well, but also looking at how far do people have to go to get food, and so looking at the larger supply system here. So just a few questions to kind of take a look at, but yes, I guess by 2020 yields will be cut in half from rain-fed agriculture. That's not to say that other areas might increase or decrease, but just looking at rain-fed agriculture in Africa. So a few of the other issues that are likely to take place is one, the infectious diseases, and so increasing the populations at risk of malaria in Africa by 170 million people by 2030, and a risk of dengue by 2 billion people by the 2080s. And so understanding what people need to do in order to adapt to this, and so is it supplies, is it changing habitat, is it moving? So all of these different factors come into play, and it's impacting humans. And then also looking at protection from disaster. So if we live along coastal areas, what does that mean in terms of floods or droughts perhaps in other areas? And so looking at an increase in the frequency and the distribution of these disasters across the globe will also impact humans. And so we'll get ready to take another interactive session here, but looking at some of the impacts of climate change on human health particularly, and so looking at malnutrition or undernutrition, and looking at how many people are killed each year by that. And so we can take a look even further and understand, is it youth who are maybe, or children who are between the ages of 0 and 5, or are they elderly folks, or are they somewhere in between, and where are these people located on the earth? And then also looking at diarrhea and malaria, and so seeing the numbers that are impacted by this, and malnutrition, and understanding access to water. So simple items and staple items that we have, a change in the climate could ultimately impact these. And so looking at overall, I mean, these are changing, but how is climate change going to impact, and who is it going to impact across the globe? So as we go through, we're just taking a look here at some data provided by the World Health Organization, looking at child mortality rates by cause and by region. And these aren't specifically climate related, but it's looking at just general trends. And so how there are linkages between a change in climate or a change in temperature and some of these diseases. So if we'll go ahead and make the clip art tool available, I want you to go ahead and label which one of these charts you actually think it covers child mortality rates in the Americas. So go ahead and place a check, some sort of symbol on which chart you think the Americas fall under.
So everyone should now have access to those screen marking tools, and you'll remember that your clip art is the very bottom button on that screen marking toolbar. And go ahead and place your check or another symbol next to the bar on the graph that you think represents the Americas. And we'll give everyone a moment to do that. So it looks like we're scattered all across the board, which is good. And it's, you know, taking a look and trying to understand these differences. And I think the way that I organize this, I think the check marks will disappear. So try and remember where you labeled for the Americas, because we'll come back and we'll actually see at the end. But right now you can take a snapshot of the check marks and take a look at the patterns that exist by all of our answers. So for the next one, I want you to do the same thing in thinking of Africa. So label where you think child mortality rates, what those might be for Africa. And we'll just take a few minutes here and let you do this, and then we'll move on. So we're starting to see a different
pattern in where we think Africa child mortality rates are based. And so kind of take a snapshot, remember where you marked, and look at the general pattern. And we'll go ahead and we'll label one more. We're not going to label all of them. But go ahead and label the child mortality rates you think that are caused by Southeast Asia, or that are caused in Southeast Asia. So go ahead and take a second to mark the board. So again, we're starting to see some shifts and some patterns, right? And so based on what our prior knowledge is, and also how we're comparing some of these regions, and so what do we know and what do we think? And so we're able to see this. And now actually, so remember, take a snapshot, and we'll flip now to the answers. And so really taking a look at the distribution of child mortality rates caused in different regions. And so we see, right, we took a look at the Americas up here near the top, and then taking a look at Africa, right, there was a shift in the pattern, became closer down towards the bottom. And then we took a look at Southeast Asia as well, so somewhere in the middle. And the World Health Organization has classified these regions and given the countries that belong to these regions, but we start to see different patterns that exist. And so some of these are based on GDP as well as education, but climate then will ultimately impact some of these. And so how prepared are people to deal with some of these changes that will occur based on a change in climate? So we'll continue on, and we'll talk a little bit more about our actual project. And I guess before we go on, if anyone has any questions, you can go ahead and type it in the dialog box. But I didn't see any questions come up, so I'll give you just a few seconds if anything did. Otherwise, I'll go ahead and talk about our project. So looking at some of those health questions that we were asking and looking about, and these patterns, where are they occurring across the globe? Our project is composed of three major components. One, we are, this is what I'll talk here a little bit more in a second, is a change viewer. And so it's a customized NASA Whirlwind tool, and for our project, it's the change viewer. Another thing we're helping to help with educators and students use the change viewers, we're developing activities specifically for high school students, but in this process we've had middle school and college students also trying out some of these activities. So while it's geared towards high school students, the concepts are based and can be applied to some of the other ages as well, including informal. And then thirdly, and I'll talk about this at the end, is offering some professional development to help educators understand how to use these tools and also understand and explore the relationships between climate change and human health. So the change viewer is really a three-dimensional visualization tool. So it's using, and it's based off of Geographic Information Systems, or GIS, and it's pulling in different data sets from different ClimateMapper tools, and taking a look at historical precipitation patterns, as well as modeled climate data. And so that's based off of different climate change scenarios that have been conducted and converted into geospatial data. We also have a population estimation service tool, which we'll see here in a second, which allows users to estimate populations based on an area that's defined by you or your students, which is really starting to look at how many people will be impacted by a change in precipitation that might impact agricultural yields. And then the third is really bringing in some of these socioeconomic data sets, which is really helping us to understand the demographics and the dynamics of humans across the globe. So all of that we'll see here in just a second. I'll go ahead and I'll just skip this for now. It's more about looking at some of the ClimateMapper data and understanding where it came from and the dates that are used as well as the spacing. So we'll come back and that's all available as well. But I guess one thing is some of these are using the A1B scenario, which is kind of, it's taking the current or business as usual approach. So the themes that we're developing, and we'll explore just one of here in a second, are looking at food security, natural disasters, rising sea levels, water resources, desertification, disease, and migration. And all of these are very complex issues, and they're very interrelated and intertwined. And so being able to examine just one pattern, but realizing that it doesn't stand alone and that everything is integrated. So looking at a change in water resources will impact the desertification, but it'll also impact food security, and it might cause migration as well, climate-induced migration. And so, but just stepping aside to kind of take an approach and look at just one of these issues using the Change Viewer. So these are the themes that we're developing the activities for. And then I'm going to now take you out, and we're going to do a little exploration now on the website, taking and exploring now more of the ChangeView tool itself. So I'm going to take you out to the website, and this will all be available at the end too, and you can type it in the box at the end. But it's climatechangehumanhealth.org. And so as this comes up, this is really our project site, but we have right now the Change Viewer, and so there's a tab here in the middle of the screen that you can click on, and when you do, this is taking you to the Change Viewer. And I want to talk a little bit about the Change Viewer, and you'll find more information below on the web page, as well as some help guides down below. But the Change Viewer is not a tool that needs to be installed on your computer. So if you are teaching at a school where you need administrative rights to install the software, this is built using a Java platform, which means it's both Mac and PC compatible, and it can be launched from the internet browser. And so when you click on this file, it acts as if you've downloaded say a Word document. And so all you need to do is you need to save this file, this ChangeView file, somewhere where you can access it later on. So whether that's in a folder for you or a folder that your students have access to, it acts as a file, so it's not an installment. There's some requirements that I'm not going to go into right now, but you know, it's some simple items, but some of the things you might run into might be a modern graphics card, and so there's instructions here on how to save the Change Viewer and troubleshooting. So one of those, if you run into some issues, you can follow along some of these documents or contact us as well. So now I'm actually going to take you out of here and show you the Change Viewer and step through some activities using the Change Viewer. So I'm going to share an application and pull this up. So I think everyone can see the application. Let's see. So, and Bryn, I've minimized that, so if you see any questions, just go ahead and interrupt me here. So this is the Change Viewer, and this is the tool. And I guess you can give a thumbs up on the viewer if you've used Google Earth, or how many of you have used GIS in the classroom. So go ahead and I guess give a thumbs up or smiley face if you have. If you haven't, it's not a problem. I'm actually going to pull that up here just a second, just to kind of gauge what's going on. So, so some of you have used GIS in the past, but GIS is really allowing us to view information on a map and analyze the information that we're working with. So when the Change Viewer comes up, it looks very similar to Google Earth, but it's actually based on the NASA Worldwind platform. And so as we bring this up, it's interactive and I can move it around. Sometimes I can see more of the globe and sometimes I can see more of what I'm calling a table of contents here on the left-hand side. So this is your map window or your view window with your table of contents over on the left. And so what we've done with the Change Viewer is we've been able to bring in various data sets from CSUN, as well as different climate science information, as well as different socioeconomic variables. And you can see all of those here in this data library. And so as we're taking a look at this, this is a wealth of resources, and we're not going to explore this all. I'll just kind of show you some of this stuff, but we're able to take a look at access to water, access to sanitation, and even taking a look at some of these other factors, such as total fertility rates or the number of vehicles per populated land area. So this combined with some climate science data sets, these are all, this is access to information to be able to view and analyze the relationship between these two. So the data library is a library. It has all of the data sets that are available, and some of them are going to be used in the activities and some of them aren't. But what we're doing as part of this project is we've created an activity tab, and up at the top you can zoom in and change the screen to see how you fit. But the activity tab is really where those 7 themes that I discussed earlier are divided, and the data sets are pulled out from that data library into a consolidated list that will allow us to explore these impacts. So looking at water resources, looking at natural disasters, looking at food security, and really taking a close look and an examination of this. So what I'm going to do here for the next few minutes is actually step you through a storyline or an activity that uses the Change Viewer, and we're going to look at water resources. But I guess 2 things, well, I'll just go ahead and if there's any questions you can ask, but I'll try and guide this along as well. And so as I see the Change Viewer, it acts as a globe. I can spin it around, I can zoom in, I can shift, and so I'm really able to examine the world. And we have these data sets, and so as I turn on, I'm going to take a look at perhaps what happens with the change in precipitation to freshwater availability and how many people might be impacted by that. And so one of the data sets that I'm going to turn on is the freshwater availability per capita. And so the freshwater availability per capita is telling me what is the freshwater availability for the number of people living in the country. And so as we see these great colors, but we don't know what these colors understand. Well, that's because the activity tab is really just a smaller consolidated library, and we need to go back to our map tab to act as and to see the legends. And so the map tab is really our live tab where everything is taking place, and perhaps where maybe I want to change the transparency of the layer because I have an underlying layer. And so I start to see what's taking place. And right now, the first quantile are those areas that are that have less freshwater availability per capita, and the 4th quantile are those areas that are high in freshwater availability per capita. And so we have some folks on the back end finalizing those changes, and they'll be placed up next week. But so as we take a look at this and we see around the globe what's what is the freshwater availability per capita? We're starting to understand it. It makes us question and ask what's taking place here. Well, for this, we're actually going to take a look at the Democratic Republic of the Congo. And so the DRC is actually one of the poorest countries in the world. It actually ranks 175th out of 177 according to the United Nations. Well, where is the DRC? And I'm not quite sure. But if I zoom in, I start to see that different names start to appear on. And because I have this data set turned on that's showing me the freshwater availability per capita by country, I'm starting to see the difference between the countries just based on the color. But if we take a look at the DRC, and what I said is the fourth quantile has a high freshwater availability per capita. And when you think of Africa, do you think of Africa as a water-rich and a water-rich country? You know, you can use the icons to show yes or no, but really, you know, kind of thinking about this. So what does this mean for the people that are living there? Well, if I see I have a political boundaries that will help me better understand what is the DRC and where it is. So as I turn that on, I can see it's pretty fresh. But political boundaries don't control water, and so I'm actually going to go take a look at the available water by drainage basin for the period of 1961 to 1990, because we know water isn't controlled by political boundaries. So as we take a look at this, we're able to turn on the freshwater availability by drainage basin, and if we take a look back at our legend, we start to see that there's certain regions of the DRC that have a higher amount of water in a drainage basin, and certain areas that have a lower amount of water by drainage basin. But compared to the rest of Africa, right, we said that it was it's one of the poorest countries, but it's actually the wettest country on the African continent, and it's home to a quarter of all of Africa's freshwater resources. We're starting to see this, right? So this is the amount of precipitation within a drainage basin. And so what's going to happen if we see a change in precipitation? Where are those patterns going to take place on the landscape? And then how many people are going to be impacted by those? So I'm going to go back and take a look, and I see I have a variety of different data sets that I want to look at. Well, perhaps, maybe I have global freshwater bodies, right? Perhaps that will tell me, well, where is the water located on the surface within Africa? And as I turn that on, I start to see, well, yep, you know, I've got some water up here and over in here, but there's a lot going on right here, right? And so this is the Congo River Basin, and starting to see, okay, this is a big area. Well, how many people are relying upon this water for either agriculture, for just water resources in general? And so we start to take a look, and we start to say, okay, what's going on here? Well, let's take a look now. So we've started to see this, and we know that water basins are ultimately, in drainage basins, have to be replenished, right? So the precipitation is helping to replenish these areas. Well, if I see on my table of contents in my data library, I see that I have a precipitation yearly average that will allow me to understand past precipitation. So if I turn that on and I just click on the box, that turns on that layer. And so if I look again, I'm going to zoom back out to Africa. And what I'm using actually here is a mouse wheel. You also have controls up here, which I can zoom out as well or zoom in. But I start to see that, right? So there's, well, what colors are we looking at here? We can start to see that there's the precipitation, the average precipitation was pretty high within this area of Africa and high within the DRC. Well, now let's take a look at future precipitation patterns, right? What's going to happen to the precipitation within this area, within the DRC? So if I go back to my Activities tab, I want to go back and I want to access a new data set. So I click on my Activity tab, and I take a look. And right now we've got a couple of different precipitation models. You can see through here that really we only have two different years or time periods. We have 2031 to 2040 and 2051 to 2060. But we have three different models, and these models are basically there to allow examinations into the climate science data that we're seeing. We know that there are a variety of different climate models out there and a variety of different projections, and so this is allowing us to take a look at some of these projections and the differences between these models. And so that's really helping to understand it's not exact, but these are projections into the future. So I'm actually just going to take a look right now at the mid-model and start to look at the precipitation patterns for 2030 to 2041. So in order for me to view that, I need to check on that layer, turn it on, and I start to see the patterns. And so, well, it's colorful, but I need to understand the underlying information. Where's my legend, right? Where's the legend? Back in the map tab. So I go back, and as the layers are added, they're added to the bottom. And so I take a look at the precipitation and the percent change in precipitation, and I start to see that there's a range from about -82% to over 200%, and based on the colors. So the darker reds are those areas that are going to see a decrease in precipitation, where the dark blues are going to be an increase in precipitation. And if I go back into the DRC, right, that's where we're interested, so I'm going to zoom us back in there. And we see that there's some variation within the DRC, right? There's a pattern and a trend that's going on. But let's take a look at 2051 to 2060 for the same model. I'm going to use the mid model. If I turn that on, I start to see a slight shift. And so I can go back to the map tab and view, and I see that they have the same legends. I'm going to actually minimize the historical one here, and I don't want to view the legend, so I just minimize it. But I'm now able to see these two patterns and see what's happening between 2051 and 2060 and 2031 to 2040. And so there's a slight change. Okay, well we're seeing this, but how many people are actually living in these areas? And if I remember correctly, I had my global freshwater bodies, and in order for me to view the layer on top, I have to turn it off and turn it back on, as the last layer you turn on is the top layer. And so I see here that there seems to be an area where precipitation is in this yellow area, which is not going to be, it looks like it's a minor decrease in precipitation patterns. Whereas in the Congo River Basin, there's, it's in green, and so there's likely to be a more positive increase in precipitation. So if I look at this area, I say, okay, well, how many people live in the Kasai River Basin, which is this tributary of the Congo River Basin here? And what I have is this population estimation tool. And so if I click on the tab at the top, population estimation tool, this allows me to calculate the number of people living there. So I'm going to call it a name, right? If I'm going to name something, I need to give it a name that I can refer to later on. And now I can draw a polygon around the area that I'm interested in, because I see that there's a slight, there's going to be a change here. So once I'm done editing and I can go in and I can, edit or cancel the polygon, it's actually going to send off a request to understand what is the underlying population of this area. The underlying population is based on global gridded world population grid out of CSUN. And so these are constantly being modified and updated over time as well. But this is taking a look at the latest version, which is based off of 1990, 1995, and 2000 population data sets. And so when I see that it's given me the land area that's being occupied by the total population. And so if I'm looking at this, what is the total population of the area that could be impacted by a decrease in precipitation? And if I look and I see that it's I have 1.39 e to the 7th. So we have to do a little bit of mathematical calculation, right, and move the decimal point back. And I'm actually going to take another and pull up another data set here, because I want to take a look at the population count that's underlying this, just to give you an idea. So I've now see how many people could be impacted by a decrease in precipitation in the Kasai River Basin. And if I turn on this population count, I can see that, well, you know, in looking in the DRC, the population is distributed within certain parts. It's not evenly distributed. And in that area of the DRC, there seems to be some larger concentrations of people living there. So I think I'm going to end there, and I think open it up for any questions that people might have. But I guess to wrap up before we do that, one of the things, if I can go back to the whiteboard, and let's see, I think stop sharing that. Go quickly through these. I think it is actually the professional development. And so as I mentioned, we're working with educators to offer professional development opportunities this summer. And so you can find the information on the website, which is climatechangehumanhealth.org. And there are 2-day workshops and where we'll be exploring in greater detail the ChangeViewer, because that's just such a quick introduction and a quick overview. But we're looking to, you know, understand the ChangeViewer, help educators develop their own lessons using the ChangeViewer, and address some of the challenges for teaching climate change in the classroom. And we're offering 2 workshops, July 9th through the 11th at CSUN, and August 1st through the 3rd at IAGT, which is in the Finger Lakes region. So applications are available on the website if you are interested. And as part of this, it's open to all, primarily it's targeting high school educators, but high school educators both informal and formal this year, and next year we're looking to do some more webinar trainings for others. So I'll go ahead and open it up if there are any questions, if you want to chat them in the dialog box, or if Bryn, you saw any that you want to address, go ahead.
Okay, and now is everyone's chance to type in your questions for Amy. You can enter it right there. It looks like we've got one from Matthias. Are the data calculated inside the polygon of interest not restricted to the resolution of the blocks? He wants to know, Amy.
Correct. So the population data is based on, it's still based on a gridded population data set, so you're still going to have grids, but it's not based on the, I guess, the pixels or those square pixels that we saw in terms of the climate data that we were there. So it is still, it's based on underlying pixels, but it's a different data set. So it's in terms of understanding spatial information and spatial data, to be able to calculate that, there's an underlying grid there.
Thanks, Amy. Does anybody else have any further questions at this point? Now's your chance to enter those into the chat and hear from Amy.
And if you don't have any questions right now, or you come across them later, you can email me at awork@iagt.org. You can also email Mark. His email is up on the screen as well. And you can also contact us through the Climate Change Human Health website as well. So if you have any questions that maybe you don't think of now, we'll be happy to answer them later on as well.
Thank you so much, Amy. We really appreciate you taking the time to give us this information. It looks like Matthias has one last question. Is the population density projected into the future as well?
Currently, we are not accessing any of those data sets. There's actually a lot of complicated dynamics that go into estimating population density based on a variety of factors of where people are living, where people might move. So currently, no. I would have liked that as well.
Thanks for your questions, Matthias. We really appreciate your participation. And Amy, thank you so much. Again, we appreciate all of this info. And now we're going to move on to the next part of our presentation with Peg Steffen.
Good evening, everyone. I'd like to thank Amy and her work with Mark. I think bringing up the health impacts of climate change brings an interesting interchange between the health, the economic, the social aspects of climate science. And I'm especially working for NOAA in the National Ocean Service, along with my colleague Bruce Moravchik. We're dealing mostly with the climate science, the collection of data and the deliverance of that data to the nation. And why, along with some of our colleagues in the U.S. Forest Service and the National Institute of Health Environmental Health branch, have been working together to develop some tools for educators that deliver some of the kinds of information that Amy was providing in terms of showing some of the health impacts of climate change, but also backing up and showing some of the larger picture views of climate and impacts and some of the underlying climate science basics. So I'm going to show you just a couple of toolboxes that are under development. One is done and has been online for a while. The other one is about ready to be released, pending some agency approval. And I'm going to start with the one that you might have seen already that is posted on the United States Global Change Research Program website. And that website is globalchange.gov. And I'm going to switch to that very quickly. And I want to emphasize that this particular URL is a place where federal research on global change is posted from all agencies. This is one of the hubs of climate change information, climate science information. And on this site, I would refer to frequently because it has some tremendous publications, including the regional impacts of climate change. And then in the resources section, it has a section for educators where you will find the Global Change Kit. I also want to call attention to the fact that the Energy Literacy Framework was recently approved and posted. And I think this is another nice area for formal and informal educators to emphasize the need for a sustainable planet. And there are lots of links to all the other climate literacy and ocean literacy documents as well. At the bottom, you'll find the Wildlife and Wildlands Toolkit, which is what I'm going to just talk about in just a few minutes today. This was set up in a bioregion section. There are 11 bioregions that have been identified, and each one of these has some information about that area in terms of the geography, the biology, and some of the unique features of the region in terms of meteorology. And then there's an indicator species that's been selected for each one of these bioregions. And I'll pick one that I worked on the Caribbean. This one on the Caribbean includes a 4-page background information. When you click on Learn More, it includes the background information and some information, as I indicated, on the indicator species. In this case, the indicator species is coral reefs. And so there are 1 to 3 activities per bioregion, in addition to the case study background information. In this case, we're looking at coral bleaching, And the activities are taking a look at the impact of sea surface temperature on coral reef bleaching. The nice thing about the case study information, too, is that while we know that climate change information can be somewhat scary for young folks, we also want to make sure that young folks know that there are things they can do. And so each multiple-page case study includes the spotlight on a species, but also profiles a climate steward. And the climate steward is either a group of people, a group of students, there might be an organization that's working to combat the effects of climate change or to help the survivability of the species that might be impacted. For example, monk seals in Hawaii. And in this case, this is highlighting some activities in the Florida Keys that are done by staff and volunteers with middle school students. So we do have this particular kit in a CD, and we have printed many of these, and they are available. If you are a professional development provider, I am happy to send to you a quantity of these CDs. We understand that educators do not always have high-speed internet access or would prefer to have PDF files on a CD. These are available to you in quantity if you should need those. Please just send me an email, peg.steffen@noaa.gov, and I am happy to send you whatever you need for your professional development needs, because these CDs also include a nice 12-minute video introduction of climate science that was produced by an interagency group, and these are available. This is available on the CD as well as on the website. And I told you that the website and the CD has set up in 11 ecoregions, and this is a list of the ecoregions and all of the indicator species that are on those regions. You can see that we've tried to find something that is interesting for the students because of the regional impact of climate change. Sometimes students find it easier to identify with an impact of climate change if it's something that's in their backyard. And so we found some indicator species, for example, a lake trout in the Great Lakes or waterfowl in the prairie grasslands. What are the impacts of climate change on these species? The other toolkit that we're working on is under the approval process, and that we have done several symposia on, is Teaching Climate, Resources for Formal and Informal Educators. We're finding increasingly that teachers are asking for more presentation material for community as well as student presentations. They want to know more basics about the state of climate knowledge. They want more information about climate of the past, that is paleoclimatology. And something that is always, I think, good to start conversations are what are the earth and science misconceptions that many children and adults have about climate science. And so we've tried to gather up reports, presentations, activities, great resources in these topics and put them on a CD that will be both posted online and will also be available in a CD format. The Earth and Science Misconceptions includes a presentation and a compilation listing of many of the common Earth science misconceptions about things like the sun and the Earth, or the Earth not revolving around the sun, for example, misconceptions about seasons, misconceptions about climate science. The climate of the past includes a lot of information of proxy data, things about coral reef, coring, tree ring data. It includes information about ice cores. The human health and climate I'd like to mention just briefly because that is something that Amy was just talking about. There's a very nice set of human health and climate activities that was put together by NIEHS, and I will show you a couple of those files. One of them is about vector-borne diseases, and they also have information and some activities on coral damage due to ocean acidification. There's some really great articles about the impact of climate change on Native American places, and the lesson plans also include a lot of great natural enquirer activities from the U.S. Forest Service. And also we are putting on there some basic information about how we know that the world is warming. Those are 10 signs of the warming world. There's a poster. The image there is of the poster, and there's an interactive website. So I think that educators will find these resources very useful for both the classroom and for presentations that they might make, as well as their own background information. Let me just briefly go back to show you the website that includes the NIEHS material.
And Peg, since we do have an additional few minutes, you can feel free to direct the participants to check out the website, either one on their own. If you would like, we could take about 5 minutes for them to explore.
Okay, great. Let me show you the Environmental Health Perspectives website. And I can't emphasize enough how much good information, especially on the regional impacts of climate, that you will find on globalchange.gov. That includes the climate impacts by region, and you can drill down and find out what will be happening to crops, to water resources, to some of the agricultural things, like everything down to honey production or maple syrup production in the Northeast, for example. I see that the note about Texas. Texas, there is definitely impacts in Texas that has a lot to do with water resources and the migration of crops north. And that is something you will want to take a close look at.
Peg, we're still not seeing the website come up.
You're not seeing the website. Hit return. Let's see if that worked.
Okay, now we see it.
Now we see it. All right. Here are some of the. Here's the list of climate lessons and food lessons. Especially the climate lessons are what we will have on the CD. But let me scroll up here to show you the website itself. This is the NIEHS Environmental Health Perspectives website, and I think for some of you, even in Texas, this is a nice listing of activities that have been posted on air, water, land, climate. Those climate lessons will be on the CD, but also here's food and health. So I think that there's a really nice set of lessons that can be woven into many different science classrooms. And let's just drill down. I want to show you, for example, the vector-borne disease. So here's the lesson summary. These are well cited with resources. We, as interagency group, had decided with the first CD that everything we put on those 11 bioregions would be able to be cited in research journals or on peer-reviewed places on the websites. And so you will find lists of resources with all of the activities and all of the case study information. We are following that same protocol for this second Teaching Climate CD. We understand that teachers want to be able to point to the resources, or if they get questioned, be able to tell other people where they got their information, and we take that very seriously. So on the What's the Buzz About vector-borne diseases, you will see that there's a nice, and this is available in PDF format. This is grades 6 through 12. I would use this in the high school biology classroom, for example. And there are lessons. There are lessons for the teachers, the students, and a PowerPoint introduction as well. And on the Natural Enquirer, I would tell you that there are some very nice interactive carbon calculators, iTree calculators that the Forest Service has provided. And these, along with their Natural Enquirer activities, are excellent for high school and middle school students as well as upper elementary. I'm happy to take some questions about this because I think this is very important, and I also want to call your attention to a recent PBS NewsHour. Let me pull up the URL here for you. Just this week that came out. The video probably won't come up, but I just want to make sure that you know that teachers are being quoted on this website and that they have done a really great job of taking a look at what are some of the issues of teachers and climate change in the classroom. And so especially there's some associated information about real stories about teachers dealing with climate change and what they're doing. So I would really suggest that you take a look at this as well. Climate change is going to be very prevalent in the new Next Generation Science Standards, which will probably be released in the next week or so. And there's already been some pushback from some segments of the population that do not want climate change in the standards. But as of this time, the National Academy is standing its ground, and it will stay in the standards, which means that this becomes something that will find its way into state and local standards and the testing as well. And I think this is something that teachers, and I applaud you all for being here tonight, need to become more aware of. This is a very complicated topic. There are a lot of social, economic, and political ramifications of climate change, but I think that for teachers who spend the time to get to know the issue and to know the underlying science behind this, that they can be a little more confident in tackling this in the science classroom. And this is my email and Bruce Moravchik's email. Feel free if you need some assistance with information. We are happy to provide that support. And so, Bryn, I think we're on to this question. I would be very interested to know the answers from our colleagues who are online tonight.
Okay, everyone, you've got your poll buttons activated, and you can select A through E to give Peg some feedback regarding your greatest need regarding teaching about climate in the classroom. So go ahead and select an answer there on your polling buttons, and if it is multiple, like Corinne there, you can type that into the chat, but please do submit at least one of your answers on the poll button so we can show that on our graph when we post it to the whiteboard. Yeah, it looks like multiple people are wanting to select more than one answer, which we can discuss here in a moment. But let's go ahead and lock those responses so we can at least see what the initial results are. So there you go, Peg.
All right, lesson plans and discussion sharing ideas with other educators. Very good to know. I would also call your attention to a website, and I will type it in the chat box right now. Climate.gov, and that is going to also have, it already has a Teaching Climate section with links to resources and lesson plans, but I would also tell you that the Climate.gov will include a lot of good background information, and some of it is written for from a Climate Watch magazine from a layperson's standpoint. The other thing I would tell you that is that Clean Network, cleannet.org, cleannet. has a wonderful site with a vetted lesson plan. So if you're looking for lesson plans and classroom activities, go to cleannet.org and do a search for your grade level and your topics, and I'm sure you will come up with excellent web activities or lesson activities that you can do with your students that has been vetted through the scientific community and also has been verified for its scientific pedagogy. Yes, and Pamela says they have a listserv and they do weekly webinars, and so I would suggest that you get tagged into that. It's a great place to share ideas with other educators of pre-K to college level. Yes, I would like to know who, if those of you that said E, other, what do you need? If you would type something in the chat box, that would be great. And while we're waiting, Bryn, were there other questions that I missed, or Paul?
I didn't see any entered while you were talking, Peg, but now is a good time for anyone to enter their
Teresa,
final questions.
Right. I see Teresa is looking for elementary lessons. All right. Thank you for that input, Teresa. I will bring that back to the group. And when you say elementary, can you be more specific? Pre-K 2, 3 to 4, 4 to 6? All of the above? Oh, okay. All right. Great feedback. Thanks, Teresa. All right. If there's no other questions or feedback, Bryn, I'll turn it back to you.
Thank you so much, Peg. That was outstanding information, and Paul has posted some additional information in the chat there, and all of this information will be cataloged in the Learning Center collection, so you'll have access to the links and the other resources that both Peg and Amy have talked about this evening, as well as the archive of this program. So please check that out moving forward. I'd like to thank both Peg and Amy for their time this evening and for sharing all of their information and resources with us. I'd also like to thank the sponsors of tonight's web seminar, the U.S. Forest Service, NOAA, and NIEHS. And here's your reminder to visit the Learning Center, where you can find over 6,000 resources for teachers, and it's also the place to register for future web seminars. A thank you to the administration of NSTA for the support of our web seminars. And a reminder of our upcoming programs on NSTA web seminars. On the 7th, we have Engineering Design Forces in Motion, Balloon Aerodynamics Challenge. Then on May 8th, Planning Your Summer PD Activities, which is an introduction to the resources in the Learning Center. And on May 14th, Chemistry of Water, Mars Exploration, Is There Water on Mars? If you're viewing this program in an archive, we hope to see you on a live web seminar soon. Thank you everyone for your time.